Hey everybody, Miss Maritello here. In this video, I'm going to talk about vertical and horizontal shifts. These are sometimes called translations. Let's start out talking about vertical shifts. So in this graph, we're going to treat the red red or orangish graph as f of x and the blue one as g of x. So you can see that we're moving along the y-axis here, moving either up or down. And we know that vertical shifts either move a graph up or down. So if we go into some specifics here, again, we got our reddish orange graph is listed as f of x, and then we got our other bluish graph listed as g of x. So hopefully you can kind of see as you're looking at the graph that we're moving, if we go from f to g, we would be going 3 units up. And of course, if we're going from g to f, then 3 units down. So just going with some more specifics, I do have the ordered pairs of part of the graph on each table. So we got the one for f of x, the other one for g of x, and I put the equations on there too. So our original graph is just f of x equals x squared, just the normal old parabola that's going through 0, 0. And then on the other one, we have g of x is equal to x squared plus 1. As we're starting to look at this, I'm hoping again you guys are seeing it's a vertical shift 3 units up. And if you were to write the function notation, it's essentially like g of x, the new graph, the blue graph, would be equal to the original one, f of x, but adding 3 units to it. And you're going to notice like that plus 3, it's being added to f of x. So f of x is like y values. So we're taking the y values from the f graph and we're adding 3 to each of them. If I actually specifically look at some of my ordered pairs, say like how negative 2, 4 goes to negative 2, 7, so on the graph negative 2, 4 goes to negative 2, 7, we're specifically adding 3 to each y value. So that's another reason that this is a vertical shift. It's literally like 3 gets added to each y value. And then that's why we're moving up 3. So like if you were to look at, say, the point negative 2, 4, and it moves to negative 2, 7, or like if you look at negative 1, 1, it moves to negative 1, 4. 0, 0 moves to 0, 3. So the x values are all staying the same. We're not moving at all horizontally at all, not left or right at all. We're just moving up and down. You'll notice all the x values stay the same. It's just the y values are changing, and they're all increasing by 3. Let's take another look at another example. So for this one, we got 2 more graphs. So that f of x graph is actually the same as it was in the previous example. It's just f of x equals x squared. And then I called the blue one h of x here. So I'm putting their tables up for your reference too. You're going to notice we have all the same x values labeled, or all the same x values on there. And then our h of x graph is h of x equals x squared minus 5. So hopefully you're noticing if we're looking from f to h here, it looks like this is moving down 5 units. This graph is moving down 5 units. So that would be a vertical shift then 5 units down. And you're going to notice the h of x graph would be equal to f of x minus 5. So it's like those y values, those f of x values, they're all of them are being subtracting 5 to get us to the new y values on h of x. So like if you look at some specific values, say the point negative 2, 4, it goes then to negative 2, negative 1. Or like the ordered pair negative 1, 1 goes to negative 1, negative 4. So the x values are staying the same, but the y values were decreasing by 5. So we're still moving vertically, moving on the y-axis. The y values are being affected. So just in general with the vertical shifts, you should see something like your new function equal to the old function values, and then plus or possibly minus a value. So that k value there is really important. That tells you how much you're moving. And we also know that if it's, plus a number, positive k value, then you're moving up. But if you see like minus some value, like say minus 5, that would be 5 units down. So we do want to make sure we're paying attention to the sign of that k value because that tells us if we're moving up or down. But again, the way we have f of x and then plus that value, that's part of what tells us that we're moving vertically from the equations. let's take a look now at some horizontal shifts. So of course, horizontal shifts move us left or right. Just think like the horizon, kind of like the sunrise, horizon side to side, horizontal side to side. So on this one, again, I got my f of x graph of that parabola, f of x equals x squared, like we've been looking at. And then now my blue h of x graph, this time it is over here. So you're going to hopefully notice if we're going from f to h, we should be moving 5 units to the left. And this is kind of interesting because a lot of people would expect the h of x graph to be x minus 5 squared, but it's actually x plus 5 squared. So we'll talk about that. So you might notice if you're looking at the y values now, we were just talking about vertical shifts where the y values were changing. If you look at the y values here, though, you're going to notice all the y values are the same. But it's the x values that are changing. So that makes sense because now we're looking at horizontal shifts. So it makes sense that then we're moving along the x-axis. It should be the x values changing instead of the y values changing. I did want to talk a little bit about, so we said we're moving to the left, yet in our equation we have x plus 5. So notice if I take that equation and I try to look for the x-intercept, of course, to find the x-intercept, I have to set y equal to 0. If I go through and I solve for the x-intercept, notice I end up having 0 equals x plus 5. So then when I solve for x actually becomes negative 5. So to get to that x-intercept of negative 5, in the equation, I have x plus 5, all squared. Because then eventually when I go to solve for the x-intercept, I do eventually end up with negative 5. So when we look at our x values, the sign's actually the opposite of what you might typically think or typically expect there. I also want to draw your attention to the fact that the plus 5, it's in the parentheses by the x. So that plus 5, it's specifically affecting the x values. And that's part of the reason when we look at the equations, that's why we know it's a horizontal shift, because we have x plus 5, the plus 5 is right in there, in the parentheses with the x value. So we know that our x values are being affected. So then, of course, we're shifting along the x-axis, which would be a horizontal shift instead of like a vertical shift there. And just again, mentioning our x values and how they change. If you look at our ordered pairs, you're going to see -2 becomes -7, -1 becomes -6, 0 becomes -5, 1 becomes -4, 2 becomes -3. So it's the y values staying the same because, of course, we're not moving it all up and down. We're just changing the x values, so that's why we're moving horizontally. And taking a peek at another example. So here we got our tables on there. So again, I got f of x is like our original y equals x squared, or f of x equals x squared. And then in the blue, I got h of x. And here it looks like we're moving 3 units to the right. So if you take a peek at the equation here, we got h of x equals x minus 3 squared. So notice that x minus 3, it's telling us that we're going 3 units to the right. And keep in mind, remember, for those horizontal functions, that the sign is often the opposite of what you would think. And again, if you tried to solve for the x-intercept is going to come out to be 3, or the ordered pair 3, 0. And of course, if you're taking a peek at this one, oh, my tables went away. Yikes, there they go. Okay, so if we take a look at our tables then, here we go. You're going to see we go from, say, if you're looking at the ordered pair -2, 4, it becomes 1, 4. Or if you're looking at the ordered pair -1, 1, it became 2, 1. So again, you're seeing the x values change because this is a horizontal shift. And all of our x values then, they should be 3 units bigger because we're moving to the right. But then, of course, in the equation, we have h of x equals x minus 3 squared in our equation. So overall then, if you're looking at like the function values here, we got h of x equals f of x minus 3. And again, the fact that like the 3 is being subtracted directly from the x in the parentheses, that's how we know that when we're looking at the equations, we're dealing with a horizontal shift, because that value is directly in there with the x, so we're moving along the x-axis. And then just kind of summarizing some of our key notes about shifts. So the vertical shifts, of course, are moving our function or our graph up or down. And then because we're moving up or down, that affects the y values, it affects the y-axis. So when we see vertical shifts from equations, we should be seeing f of x plus k, or f of x minus k. And of course, if we have f of x plus k, that's going to shift us up. if we have f of x minus k, that shifts us down. Now, horizontal shifts, on the other hand, are always moving us to the left or to the right. So those move us along the x-axis. So then for those, we're going to see that k value right in the parentheses with the x because it's affecting our x-axis. So you might see f of x plus k, which would move us to the left, or f of x minus k, which would move us to the right. And again, notice those parentheses are super important there because they tell us that that's a horizontal shift. Hopefully this was helpful. Thanks for watching.